Good morning, all the pilots. The presentation will be given at Drone Japan's Shibuya-san and Sunohara. So as Kiichi mentioned on the first day, Drone Japan runs a school for all the pilot engineers and also outsources and supports development work for drone manufacturers and end users. This indoor application is being developed based on the needs of end users. In Japan, there are various needs for using drones indoor spaces. For example, monitoring construction progress in tunnels, inventory management in warehouses, factory inspections and environment measurements, and night patrol in buildings. Drone solutions being rolled out in Japan. One is Skydio, which you are all probably familiar with. As you all know, this is in collaboration with NVIDIA and is controlled using SRAM. The second is Flyability Helios, which also uses computer vision and radar mapping to control drones using SRAM. The third is Liberaware's IBIS. Liberaware is a Japanese drone manufacturer that is known for its very small drone that can fit into tight spaces. These three are no, unfortunately, or the pilot. So in this situation, Drone Japan has announced the drone equipment with modal AIs, AI camera, voxel, and development cases with several users are underway. This drone is called Quick Indoor, and its unique features include the adoption of modal AI, which places more emphasis on positioning rather than mapping, and the ability to customize the payload. For more technical session, change the presentation from me to Shibuya-san.
Hi, so let me explain a little about tips and our recent efforts. So during flight, we encountered challenges with vibration, which affects localization by the voxel vision system. So to address this, we made efforts to reduce vibration impacting both the voxel and the flight controller. Specifically, we implemented dampers, simple dampers that minimize the vibration transmitted to the voxel and flight controller. And additionally, to provide a reliable backup in cases where voxel output may be less accurate, we incorporated an auxiliary sensor called here flow, an optical flow sensor that offers additional data like velocity. And next slide. So this slide shows the specification of voxel. We will not describe the details of voxel because time is limited today. And so if you are interested in and have any question about the voxel, so please ask Eric-san from Model AI. Yeah. And we are hoping to collaborate with Model AI to integrate voxel 2 into our quick indoor model drone to update its positioning and navigation accuracy. Next slide. So next is about our indoor solution. So to fully leverage the capabilities of Model AI, we have customized Q-ground control to support indoor drone navigation by using a 2D floor drawing as a map within QGround control, users can create waypoints for automated navigation, as well as outdoor GPS waypoint navigation. So, and next is how to use the app, our app. First, adjust the scale of the 2D indoor drawing and upload it as a map in QGround control. Create waypoints for automatic navigation, or auto navigation on that drawing. For internal processing, virtual latitude and longitude coordinates are assigned to the map. It is possible to assign actual latitude and longitude coordination, but we have but we have adopted this specification because users rarely know the latitude and longitude on interior drawings of buildings. At the flight site, simply set the drone at the designated point and start automation to begin automatic flight. So, yep. So next is kind of demonstration. Let us show you a short demo for our indoor drone solution without flight for safety. So this is our app. So for indoor flight, as we can see, this is not drawing, but 5-meter grid for demonstration. So in real use case or real situation, we should see real drawing of the building. So, so Sunohara-san moves drone by his hand, and we can see the drone is moving on the map. And again, the grid is 5-meter. Yeah. So he turns a corner. Yeah. Oh, okay. And also, we added a function to know the quality of model AI's output. So let me show the data. So please wait 1 second. So I changed the parameter to show, to see the quality of the model AI's output. And so, yeah, in odometry modeling message, we can see this quality. So now it shows it is 100%. And so this graph should move. So, yeah, hopefully. So the line is very thin. It is hard to see, but so this graph says the quality is between 50 to 100%. Thank you. So Yes, lastly, we worked with Randy-san on this indoor drone project, and he helped us improve many features. I'd like to invite Randy-san to provide insights into some of the technical advancements, including object avoidance in automation and switching between voxel, AI cam, and optical flow, and the indication of voxel confidence rate. Randy-san, would you please share your perspective on these improvements?
Yeah, so yeah, three fairly small but important changes. The first one is object avoidance in auto modes. So most of you may know that we have Dijkstra's and bendy ruler, but those are actually path planning. So if you have an object, the vehicle will try and get around it. In fact, actually, what you really want is just for the vehicle to stop. That's we call that simple avoidance. So we have that implemented. I can't remember immediately if we've merged that to master or not, but there's certainly a PR for it. The reason that we didn't do that for a very long time was just because we didn't want the vehicle to get stuck. There was this worry that, you'd have a mission, it might be on the other side of a set of trees, and it would just get stuck. But in any case, it's there, or it's almost there now in master. Also, the second one we've actually had for quite some time, although obviously we made some improvements for this project, and this is the automatic switching between EKF sources. So we have a number of scripts that allow you to change between, for example, GPS and external nav, or GPS external nav and optical flow. So for this project, we just needed a simpler version, essentially, to switch between voxel and optical flow. So that is also there. That is definitely in master now. And the nice thing, I guess, about Lua scripts is that you can customize them and you can change the heuristics that are used for making the decision of sensor you want to use. So yeah, we've used one of the important criteria is the voxel confidence number that we just talked about. So when that drops below 25, it will switch over to optical flow. There's actually also a small change to how the EKF deals with the switchover. An external navigation system was originally treated just like a GPS in that it provides an absolute position. So we would find that if you went from the voxel to optical flow and then back to voxel again, that the vehicle's position would jump on the map. We fixed it so it doesn't jump, or at least it's optionally does not jump. I'm not sure if that's a little too, not sure if you understand exactly what I mean, but when you switch from a non-absolute position system like optical flow to one that does provide an absolute position like a GPS, normally the vehicle's position will jump on the map. And if you're in the middle of a mission, right, a mission is also absolute positions. And so as the vehicle switches to the absolute source, it flies back. It can fly, a few meters at least back to the mission coordinates. We don't want that in this case because a voxel is not really an absolute position source. So yeah, we fixed that as well. You can optionally change that behavior. Yeah, and the last thing is just making sure that the voxel quality number is visible to the pilot. So that's coming through on the Mavlink odometry message. Is that good? Okay. Thank you very much.
Time. So, any questions? Oh,
Hello. Does the voxel provide optical flow also, or is that a separate chip?
thank you for your question. So in my understanding, voxel does not provide optical flow. So it provides position and velocity and yaw.
Thank you.
Hello. Really great presentation. I worked with Pedro last year for GSOC doing some indoor path planning with Ross, and one of the difficulties we ran into was how to arm the vehicle when you don't have GPS, and then how to align the yaw when you start up with your local map frame. I noticed that there's also been some wiki improvements. Could you sort of speak on if there's been any improvements for people looking to set this up and how to get started and deal with the indoor challenges that we don't have GPS and yaw?
Thank you for your question. So still we are tackling the same problem. So we should set the EKF origin when before the flight, and also we how can I say set the drone very accurate for the your direction. Still.
Cool, thank you.
Slightly less of a problem in this case because we're just using optical flow and voxel. So when we switch over to optical flow, we actually stop using any yaw source and we just run on the gyros. So it's body frame and it doesn't cause as many problems as say, if you're using GPS or switching between external nav and compass, which could have very different angles. So yeah, we've avoided that problem.
Hi. Thank you for the great presentation. I'm assuming you're using the EKF source switches to switch between the two different navigation schemes, localization schemes. How seamless was it? Did you see any jumps when you were switching between optical flow and Model AI, or was it very smooth? Like, what was your experience with that?
Oh, thank you for your question. We don't see the, how can I say, huge jump often, so it is kind of stable, we think.
2つクエスチョンがあります。一つは、オプティカルフローで、組み合わせがベストなものは何だったのか、ヒアリンクなのか、ヒアフローなのか、その辺ちょっと教えていただきたいというのが一つ目。で、二つ目は、私、ボックス1を持ってるんですけども、やっぱり熱が出るので、その辺の熱対策等をもしやっておられたら教えていただきたいと思っております。よろしくお願いします。
The two questions from Murata-san. First one was, which is the best optical flow sensor? And the second question was, he also has a voxel camera and he notices that it gets very hot and he wonders if any steps were taken to cool it down.
Thank you for your question. So first in English, so first about the optical flow, we didn't test a lot of sensors, so we just brought the drone. So yeah, it is our solution. So まずオプティカルフローはですね、そんなにたくさん試したわけではなくて、ヒアフローが軽くて小さいですし、向いているのに使っていますということと、やはりボクセラーの熱が出ますので、ファンをつけてですね、熱を逃がしています。ありがとうございます。
ありがとうございます。Thank you.
For your question.
Hello, nice presentation. I want to ask, what is the performance of this system when you are having very much dynamic environment, like a lot of people, a lot of flying things around, I'm asking about the future.
Oh, thank you. So, thank you. And so we didn't test in very dynamic environment. But there are some, how can I say, tips to use voxel well. So first, if the environment is too dark, so the position and velocity is not very reliable. And also, so if the, how can I say, floor is too shiny, so in that case, so the position may, how can I say, is not stable in some cases. So didn't I answer your question? Thank you.
I can add a little comment there too. One of the nice things about the voxel, one of its many nice things, is that it gives you that quality metric. So when we first started the project, we actually did not have that quality metric passing through, and it's just a single number, but it's extremely valuable because that's in that way the Lua script can look at the camera, it can see, oh, it's below 10, it's -1. Well, we definitely can't use it anymore. So and we can just switch to optical flow. So that metric was really super valuable for keeping the system reliable.
Thank you.